Not long ago, this topic of iteration was in the A-level domain, but it's been brought back to GCSE and, well, I question that decision. I think a lot of GCSE students find the notation and this whole concept quite difficult. And this question is probably as hard as the iteration questions go. But I'll take you through it step by step, and I think you'll get it. It's not as difficult as it at first appears. Iteration is a way of finding roots, and a root is where the curve crosses the x-axis. If I set up a pair of axes and just draw any curve that might go through those axes, so if this is the point x equals 1, and this of course is the line x equals 0, this, therefore, is the root, and just like the question, it is lying between x equals 0 and x equals 1. But how do we prove it? Well, the trick is this. If you look at the value of the function at x equals 1, you can see that it's positive. And the value of the function at x equals 0 is negative. So if we in turn plug x equals 0 and x equals 1 into our function, and see a polarity change and the fact that the function is continuous, and there's no reason to suspect that this function x cubed plus 4x minus 1 is not continuous, and if we see that polarity change, then we know that the function has somehow crossed the x-axis and its y values have turned from either negative to positive, or if the curve went the other way, from positive to negative. So that's the technique, and now let's just put our values in and see what happens. So when x equals 0, y equals, well, these two terms disappear, y equals negative 1. And at x equals 1, y is equal to, well, this is 1 plus 4, 5 minus 1, y is equal to 4. So in a way, I've drawn the diagram roughly right. This value is 4. And this value is negative 1. And just like my example, the curve must go through the axis because its value changes from minus 1 to 4. So that's part A. And what happens now in part B is we say let y equal 0. So we're at this point of the curve. And our curve becomes 0 equals x cubed plus 4x minus 1. And we can rearrange it in the form that the question now states by just putting the 1 on the other side. Now they're asking us to do a further rearrangement. Can it be arranged into this? Well, the tricky thing is that we've got two x's here. So which one becomes the subject? It should be clear that we're using this x as the subject. Because if you look, we've got x cubed untouched over here. Yes, I know it's divided by 4. And because we've divided the whole equation by 4, this is obviously unglued the 4 from the 4x term here. So it is 4x that initially becomes the subject, and then we divide through by 4. So let's just do that. 4x equals 1 minus x cubed. So now we've got to divide through by 4. So therefore, x is equal to 1 over 4 minus x cubed over 4. And that is your answer and proof of part B. Now you notice that iteration has not been mentioned yet, but this is where it comes in. Remember that this version has been produced by assuming y is equal to 0. This is not the original function of y is equal to x cubed plus 4x minus 1. We've substituted y is equal to 0 and we've disposed of y effectively, and we've got x in terms of another x. And what that means is that we can substitute a value for x, and putting it through the machine of the right-hand side of the equation, we get a new value of x. And then if we put that new value of x again into the right-hand side, we get a new value of x. And we keep going. And the strange thing about an iterative formula, it homes in on the root. The actual value of x, which is here. That is the value of x we're aiming for. So in part C, they're suggesting that we start with x equals 0, which is here. So this term, on the first go, will disappear, and we'll actually get the answer a quarter, but we'll see that in a moment. But if we start with x equals 0, we get a new value, which will be x equals a quarter. Then we put a quarter in here and get a new value for x. And a new value, and a new value, and so on and so on. Now the calculator is brilliant in this, and I'll show you exactly the way to solve this really easily with a calculator. Starting with x equals 0. So here's the iteration formula, and all they've done, they've transformed the x to the new value, and they've transformed the x cubed to the old value. And it's written this way. Why do we do all this end business? Well, we're going to produce a series of results. They've only asked us to go around the loop twice, so we're only going to go up to x2. But this could be a series of results getting closer and closer and closer to the root. In fact, we're climbing up a staircase, but a staircase where the steps get smaller and smaller each time, and eventually the calculator will run out of decimal places and you'll say, well, the root is at a certain point. But you can see why this whole process is really designed for machines. It's an awful lot of calculations with many decimal places if you do it by hand. But let's see how the calculator does it. So to set that initial value, what you've got to do is you've got to type in 0 and then push equals. Now button pushes I'll try to write out in white. And what this has done is it set the memory in the calculator called answer. It has set answer to be equal to the value of 0. So now we've got to enter the right-hand side of the formula. So the button pushes on the calculator are 1 divided by 4, and you could probably set that in a bracket, take away. Now this will be answer raised to the power of 3 divided by 4. So when I now push equals, the answer I get on the calculator is 0.25, which we sort of predicted, because if this guy is 0, the new value of x will be a quarter. And of course, this is your new value of answer. And if I now push equals again, I will get the next version of x. This will be x2. And the calculator comes up with 0.24609. And on it goes. The question doesn't actually tell us what limit they want this to, and I would think you could probably safely do the chop there. So I'm going to say that x2 is equal to 0.246, and that's to 3d. So that is the estimate for the root. So we think the curve crosses at 0.246. So I've pushed it looks like I'm at about 0.5, but no, in reality, the curve in their question crosses the axis just below a quarter of the way between x equals 0 and x equals 1. So not a bad guess. So I hope that's cleared up a little bit about iteration.